everyone. Now we will learn about X-linked dominating disease. Now X-linked dominating disease, the rules are, for X-linked dominating, the rules are all affected males should have affected mother and all daughters will be affected. Okay, once again just recollect it. Like say suppose we are having this and this, male and the female chromosomes and their contrasting alleles. Now if we are going to talk about dominating means this for a male, because it's an X-linked dominating, capital A. And when we are going to talk about female, so the condition should be either this or it can be capital A, small a, either this. So that is for the female and this is for male. Now the rule is that all affected males, whatever they are, all affected males should have affected mother. That means in the previous generation the mother is affected and all the daughters in the next generation, all daughters will also be affected. Then mother can, in an X-linked disease, mother pass on the disease to the son and father pass the disease to the daughters. Okay, this is also a rule. Now we have to note one thing, that why this is happening in X-linked diseases, the males are more affected. What is the reason behind that? Because they have only one X chromosome and if that X is diseased, that means they have no option, the male will be diseased. But here in a female, when they have 2X chromosome and out of the two, if the one is dominating and the other is recessive, heterozygous condition, they have an option of being carrier, not a sufferer. So that's the reason why X-linked diseases, males are more affected, and the reason is that they have only one X chromosome. Now I'm going to tell you the shortcut, how with the help of a simple pedigree we can identify with these rules, how we can identify that whether it's a pedigree of dominating or recessive in nature. First of all, that we have to find out. And the second one, if it is dominating and it satisfies this condition, that means it's an X-linked dominating. If it is not satisfying this condition, then it means it is an autosomal dominating. It says autosomal dominating. If suppose it is not dominating, then it is recessive, and under the recessive yes condition, then it is X-linked recessive, and if it is no condition, then autosomal recessive. Now let's see. All affected offsprings have affected parents. That means the affected offsprings will have affected parents. Out of the two, the one will be affected. This condition, if this is there, all affected offsprings have affected parents. If this is true under such condition, if yes, then this condition is there, yes, then we'll have to check. All affected males have affected mother and affected daughters. If this is there, the affected male has affected daughter. That means, what is this? This is dominating because present in both the generations, and along with dominating, it is also called X-linked dominating disease, and this will prove itself. Now, if suppose it is not proving this, that say suppose in place of this, we have this as a condition, and the condition is that it is present in both, one dominating, but out of the both we'll have to see that all affected males are affected mother, no, affected mother is not there, and affected daughter, no. This condition is not satisfied, so in place of this it is an autosomal dominating trait or character. Fine. So this way, just looking at the pedigree chart without using any pen or paper, you can analyze the situation. Now, if suppose it is not dominating, say it's not present in the next generation. We can pick up this as an example. So if it is not present, because all affected offsprings have affected parents, we can do it in a reverse manner. We can make the parents unaffected and this as one of them is affected, suppose. Now, under such circumstances, all affected offsprings have affected parents. No, they are not. So that means it's not going for yes, it's coming for no. And if it is no, that means it's a recessive disease. Now, out of the two recessive, X-linked recessive or it is a autosomal recessive, we'll have to find out. Now, X-linked recessive, what is the condition? If all affected females have affected father, no, female is fine and father is also fine. All sons are also affected. No, this is not coming down. So we'll have to see that what is it. This is, that means this can be no, and the condition comes up autosomal recessive condition. Autosomal recessive means, that means we are going to talk about autosomes, and autosome, say under this condition we have a heterozygous, under this condition we have a heterozygous. Now here when this is normal and we are saying autosomal recessive, that means the normal condition is this, maybe capital A from mother and small a from father, and here it is both, because recessive condition, both small a from the parents. If the child is receiving, that means it is under this condition, it satisfies this condition and autosomal recessive in nature. I hope with this shortcut also you can get it. In the next video I am coming up with 3-4 more examples in which the big pedigree charts are there and you will understand them in a clear manner. Thank you.